What do two lines with the same slope and the same y-intercept do when it rains? They coincide. And you might have to wait to the end of this lesson to know why that is funny. So we're going to start with parallel and perpendicular lines. And one thing I wanted to point out is this symbol right here where it looks like an upside down T, that means perpendicular. And I use a lot as shorthand in your notes to make everything fit. And the reason we use that is you can see there are two right angles there, implying that it's perpendicular.
In the original line, we have a slope of 5, which is the rise, over 1, which is the run. So the slope is 5 over 1, or 5. Now I'm going to rotate the line by 90 degrees around point A. And you can see that the slope of the new line, the rise is -1, and the run becomes +5. So the slope is -1 over 5. You might have noticed that the run, which was horizontal, is now pointing vertical, and the rise, which was vertical, is now horizontal. So it's as if the run and the rise switch from the original line if the lines are perpendicular. Additionally, if two lines are perpendicular, then the slopes are going to have opposite signs. So if you have one line is negative, the other will be positive. And if one is positive, the other will be negative. Another way of saying this is perpendicular lines have negative reciprocal slopes. That is, the negative means change signs, and reciprocal means flip.
So now we're going to take a look at an example. We're going to find the equation of a line perpendicular to this that passes through the point -6, 7. So you can see that this equation here is in point slope form. There's my slope. My point is 1, 4. I don't really need the 1, 4 because the only thing I really need here is the slope, -3. I already know what point it's going through. So for step 1, we're going to find the slope, which is a negative reciprocal of the original. So I know my original slope is -3, but here I put it as -3 over 1. Why? It's easier to flip a fraction where I have a numerator and a denominator than it is to do a whole number. And also 3 divided by 1 is 3. So you can also take any whole number and put a 1 under it and you haven't really changed it. So our perpendicular slope is 1 over 3. Our next step is to use this slope with this point using the point slope formula. So y minus y1 equals m times x minus x1. Y minus 7 is 1/3 of x minus 6. Or minus a -6, that's +6. Distributing the 1/3, I get 1/3 x, and 1/3 of 6 is 2. Adding 7 to both sides, and I get 1/3 x plus 9. So here you can see the point slope form of the equation, and there's the slope intercept form of the equation. To find the equation of a perpendicular bisector, you're going to have to remember that a bisector bisects. It cuts in half. So the segment, we need to find the midpoint. And then we also need to make it perpendicular, so we're going to find the slope of the segment and use the negative reciprocal slope. So our example, we're going to find the equation of the perpendicular bisector of segment AB, where A is -2, -5, and B is 4, 3. So I'm going to use, I could use that x of p equals x of b plus fraction times x of e minus x of b, where we're using the fractional distances. But for midpoints, your math chart is probably the easiest, and this is the formula it uses. I show only the x-coordinate formula. The y-coordinate is just like it, except for y. So substituting in for x, I get -2 plus 4. So it's like I'm averaging them, adding them, and then dividing by 2. So I get 1 for the x-coordinate and -1 for the y-coordinate. So there's my point. It's a perpendicular bisector. I know it's going through 1, -1. Now I need to find the slope, so I can take the negative reciprocal. Well, I substitute these both of these points in for the slope. 3 minus -5 over 4 minus -2, 8 over 6, or 4 over 3. To do the perpendicular slope, I have to take the negative reciprocal. So I change signs and flip, which gives me -3 over 4. So I have the slope, and here's my special point. I can use the point slope formula. Substituting in, there's the -1 goes in for y1, and the 1 goes in for x1, and there's my slope. And I can make that y plus 1, and here I distributed the -3/4, -3/4 x plus 3/4. Subtract 1 from both sides, and I get -3/4 x minus 1/4. So here's the slope-intercept form, has slope of -3/4, crosses the y-axis at -1/4. Here's the point slope form, where I can say it goes through the point 1, -1, with a slope of -3/4. So for further reflection, what happens to the rise and run when a line is rotated 90 degrees? And how do you find an equation for a perpendicular bisector of a segment? Hopefully you remembered you need to find the midpoint where the segment's being bisected. And you also need to find the slope of the original segment and do the negative reciprocal.